For today's lesson, we are going to solve this inequality question from 2021 Canada National Olympiad. So n is a fixed positive integer and all the ai are positive real numbers such that the sum equals to 2 to the power n minus 1. We are asked to find the minimum of this expression. If you observe closely the numerator of the term and the denominator of the next term, then probably you will have a good idea to solve this problem.
Pause the video now if you wish to solve it. Keep watching the video once ready.
So let's call this as j. For each of the term, it is of ak, then 1 plus a1, a2, all the way to ak minus 1. And this can be written as 1 plus a1 plus a2, all the way to ak minus 1 plus ak, over 1 plus a1, a2, all the way to ak minus 1, then minus 1. So with this, j can be written as a1 over 1, that is 1 plus a1 over 1 minus 1, plus 1 plus a1 plus a2 over 1 plus a1 minus 1, and all the way to 1 plus a1 all the way to an over 1 plus a1 all the way to an minus 1 minus 1. So what we have here is 1 plus a1 over 1 plus 1 plus a1 plus a2 over 1 plus a1, and all the way to 1 plus a1 all the way to an over 1 plus a1 all the way to an minus 1 and minus n. Now you see that the numerator of this term will be equals to the denominator of the next term, and it is always true. And there are n terms here. Using AMG inequality, this will be greater than or equals to n, the product to the power of 1 over n minus n. The product will be cancelled off except for the last one, and over 1, the first one. Now we already know that the sum of a1 until an is equals to 2n minus 1. So here this will be equals to 2 to the power n. So this is equals to n 2 to the power n to the power of 1 over n. And 2 to the power n power 1 over n will cancel off. It means that this is 2n minus n, and this is equals to n. So this means that j will be at least equals to n. But we need to check whether the equality holds. If you enjoyed this video, please like, comment and subscribe. The equality holds if and only if each of the term is the same. So let me write it. So let me write it here. Equality holds if and only if each of the term the same. And if each of the term the same, it must be equals to 2. So 1 plus a1 over 1 equals to 1 plus a1 plus a2 over 1 plus a1 all the way to 1 plus a1 to an over 1 plus an 1 plus a1 all the way to an minus 1 equals 2. So 1 plus a1 over 1 equals to 2. It means that a1 has to be equals to 1. If a1 equals 1, from the second one, 1 plus a1 plus a2 over 1 plus a1 also has to be equals to 2. 1 plus a1 equals to 2. So it means that a2 has to be equals to 2. And you can check that A3 has to be equal to 2 squared, and so on and so forth until AN has to be equals to 2 to the power n minus 1. So this means that J equals to n is achievable. This is true if and only if AK equals to 2 to the power of k minus 1 for each of the k from 1 to n. That's all for today's lesson. I'll see you again next time. Bye bye.